Hi guys, so I want to do a quick video on how to turn curved surfaces like this into something flat that you can laser cut or scratch build. So when I first designed my F86, I had to go with this canopy that I made from just a couple angled surfaces and stitched together in the patch environment. But to be honest, I wasn't very satisfied with how it turned out, or at least how it looked. And I really wanted to learn how to get a curved surface into something flat and laser cuttable. And so this design here for canopy is something that I actually just got from my smooth design, the one that I did before I actually did a foam board version. I actually catted this first, and the whole reason why I switched to this guy is because, the reason why I switched to this one is so I can have flat surfaces that I can, laser cut, but I had to ditch all those nice curves. But to get to the point, I saw, or rather I knew about Andrus's X29, and I saw that it had this super slick canopy, and I really wanted to replicate that on my own F86. So I actually just messaged him, and he basically told me all about how he exports DXF, which is actually quite similar to how I do it for these flat planes. But in order to turn this curved surface into flat planes that he exports, he basically uses this whatever curved surface you're working with as a tool or a guide, if you will, for turning those into flat surfaces. So I'm just going to speed through my timeline real quick. I'll go over this more in detail later. So he uses it as a guide, and basically you want to make something like this. And once you have all of these little flat panes, if you will, once you have all of these, you can do what I've showed you before in the previous video on saving each one as its own DXF, and then you stitch them all together in AutoCAD. And even though it's not perfect, these should be a good approximation, and then all you have to do is connect it with a spline to your best guess. So you would have like these points to go off of, and you connect that with the spline with your best guess, and hopefully using that you'll get a much better approximation than if you just projected it flat like this, or just projected it flat like this. Yeah. So I'm gonna go ahead and show you the process that I use to break up that curved surface. So starting from here, alright, so I've got my canopy, or whatever curved body or whatever surface you're working with. First thing I did is I've got this plane here. I just drew 3 vertical lines up to a height above my surface. Then I used each line as a splitting surface. If we can look at one of these. Right, I select the body, I hit that line, hit extend splitting tool so it splits the whole thing, and then it splits each one. I've turned off the other ones, but here you can see all of them. Then now that you've got your curved surface split along that length, I chose that length because I wanted my panes to be stitched left to right, or composed of long strips running from left to right. Okay, so now that you've got them all split, you can then create a sketch. Not that one, this one. You can create a sketch on that flat surface, okay? And if we go and look at it, what I did is I drew a line going from here to here, so that just forms your right side and bottom side sketch enclosure. Then I just clicked here, here, here along the path of this curve, so it intersects at those points. I chose 6 because that just seemed like a good number of panes that I could work with. I think you can get away with a little bit less, but I mean, obviously the more panes you have, the closer of an approximation it is, but of course it will take you even longer to stitch together in AutoCAD and as well as export to AutoCAD. So I just went with 6. Then you could leave them arbitrarily spaced, but just to get something that was mildly evenly spaced in terms of how big the resulting planes would be, I just thought a good way of doing it is setting all those segment lengths as equal, and that seemed to work out pretty fine. So once you have one of them, you obviously will need another sketch, and I did that off of the next body. I think I've turned that sketch off as well. Yep. And oh, by the way, you only have to do 1/2 for most of your curved surfaces. If your curved surface is asymmetrical, obviously you have to do the other half, but I chose not to because I knew both sides would be symmetrical. And I also went ahead and did this one down here. Basically, I just selected the bottom side of this body and sketched the whole thing. One quick note for this one. So I did space them out equally based on segment length, but when it came to the final section, this length, which would have been here, I thought it would have been nicer to have the actual curve in it. It's not really necessary because I'll have to approximate it with a spline later, but I did it anyways. Basically what I did is I drew the spline in first, and then I have this secant line running from this point to that point, and I used this secant line to do the equal dimensioning, and the spline here I just approximated according to what the body is, what the actual body is. So if for whatever reason you don't have enough of these secant lines to approximate it very well, and you really need to write down per se what the actual curve is, so maybe on your surface your curve runs something like that within the length of one of these panes, so you can draw in your spline if you needed to save that dimension just for like one segment. If it was for the whole length, then you might as well just go with more panes. Okay, so now that I had that one, I went ahead and I made that loft. We can turn off our guiding bodies. Okay, so for this line here, I just did on a plane parallel with in plane with the XY plane. And I just drew a line from there to there. I use that as a guide rail for this loft, so I just selected that face and that face. I can go ahead and redo it. So sometimes if you select the faces in the wrong order, it might give you it might not actually display your... Actually, let's turn off the rail. I think if we turn off the rail, it'll break. Nope. Okay, that works. So sometimes the rail isn't necessary, but sometimes you do need it. So I made that rail because I needed it earlier. Fusion, I guess, was nice enough to actually display it. Yeah. So if you select, if you select the profiles in a special order, it seems, or if Fusion just isn't cooperating with you, it can create things in a way that you don't expect or you don't want. So if for whatever reason you aren't able to get the other version that I was able to get, sometimes it's nice to have a rail. So I just select that rail, and that does tend to fix things up. And all these panes run more lengthwise now. I don't know if you saw it earlier, but the other version had a more diagonal line, if you will, and I wasn't looking for that. You can try and drag around these kinds of lines, but I'll be honest, sometimes it gives you unexpected and unwanted behavior. So you just have to remember that this is just an approximation, right? So even if these lines aren't exactly in the right place, you won't be using them anyways. You're going to be connecting all of these with a spline and basically discarding all these fold lines, right? You're only using the points, so don't worry too much about them. It'll just mean that you might have a little more than the 6 panes than you started with. And remember, of course, when you're projecting these panes, you can choose to say, draw a plane between this point, and that point, and projecting both of these surfaces onto that plane, and then exporting the sum, or rather both of those panes at the same time. And so since the pane will be running from, say, here to here, you'll lose a little bit of accuracy, but the point is you can basically discard or ignore the fact that it's giving you more panes that you want. As long as it's connected by a surface, then you're pretty much good to go. So that's that half, or that the back half of my canopy. The next section is probably by far the easiest. It was just create that sketch, connect it with a loft. This tip section didn't give me too much trouble. All I had to do was create a sketch on my front portion and the back of that. And once again, when I connected it with a loft, it was pretty funky and gave me way more panes than I needed. But like I said, I can ignore them if I wanted to. Sometimes if the planes that you loft between are connected at a point, it can give you funky behavior in the same way that it did back here. So I remember that I actually separated these two surfaces with a really small gap because it was giving me problems. So I haven't bothered to see if this would break if I connected them. But just a quick note, if things do break, if you can't get a successful loft between two surfaces, just try separating them by a pretty small, negligible distance. So yeah, once you've got this surfaced or very subdivided body for the right half rather, I just mirrored it so I got both halves. You don't need to. I just mirrored it so I could see both at once. I'm going to turn off the sketches because I don't need them anymore. And so then finally, the process for exporting all of these panes to DXF and to LaserCut is really the same process that I outlined in the previous video. Even more so for these small panes. I talked about how you want to have like a notch, I would say, standardize it for the top right corner. Just once you've projected the sketch, just draw a quick dash to mark the top right corner, and that'll save you a lot of time in figuring out how these panes are intended to connect. But otherwise, that is the method for turning curved surfaces into something flat and laser cuttable. Shout out to Andres for helping me with this. He had a slightly different idea, but a slightly different way of doing it rather, using cuts and extrudes. But this is the way that I'm doing it with lofts. If anyone's got a better idea or a better way of doing this, please let me know. Other than exact flat, because that's a subscription fee. Otherwise, thank you for watching.